welcome to Easy Alim Learning Simplified. My name is Ruth, and today we are going to be looking at Form 3 Chemistry, and the topic is mole. So, today we are going to be looking at the beginnings of the mole and the mole specifically on the Avogadro's constant, and then we are going to practice a few questions in regards to this. So when you talk about mole, mole is usually defined as the mass of a substance that contains as many particles. These particles can be atoms, it can be molecules, it can be ions, as the number of 12 grams of carbon. So 12 grams of carbon was the one that was used, carbon 12, uh, when the mole was being derived. So in the above definition, you notice that 12 is the mass number of carbon. So 1 mole of carbon atom has a mass of 12 grams. So the relative atomic mass, which can be written as RAM, is the number just above the element in the periodic table. So you always notice it here at this superscript. So this number is also called Avogadro's number, and it is usually written as 6.2 times 10 power 23. Some other books write 6.0. So it's just the decimal, but it's just a whole number 6 times 10 power 23. So what we have discussed from the definition is that 1 mole of any substance is equals or contains 6.023 times 10 power 23 particles. So just like we usually use, like let's say for example dozens. When you hear the word dozens, you know that we are talking about 12. So if I want like a dozen of eggs, I know I want 12 eggs. If I want a crate of eggs, I know I have 30 eggs. So in the same way, we have those values to identify a certain number of compounds in our daily day-to-day life. In the same manner, because particles are so small, we can't use things like dozen and 30. We usually use the Avogadro's number, which is 6.023 times 10 power 23 particles. So this is the number that is now used to represent these particles because they are too small. They are too small. So every 1 mole of a substance has 6.023 times 10 power 23 particles. These are so many particles, but that is now where the mole comes from. So 1 mole is equals to 6.023 times 10 power 23 particles. So if you were to take 1 mole, you will get the same value. If you were to take 2 moles, it means you have to multiply the same. It means it's double the number of particles in that substance. If you were to take 0.2, it's 0.2 amount in that substance, or the particles in that substance. So when we do that multiplication, you notice that the number of uh, zeros in the 10 reduced. This is because of the decimal place. So make sure you're able to see that. So you can use your calculator to get these calculations. If you are getting 0.0065 moles, you will get that. So the mass of 1 mole of a substance is usually referred to as molar mass. You can see even from the word molar, it means 1 mole. And the molar mass of an element is equal to the relative atomic mass in grams of the same element. For example, the molar mass of carbon is 12. You always be given these values when you're given like questions to calculate. So it means that every 1 mole of a carbon has 12 grams. So you can see we have equated the number of particles to the mole and to the mass. So it is possible for us to do this. So these three can be used interchangeably, especially depending on what question you have been given. So the molar mass of sodium is 23 grams, which is equals to 1 mole, which is equals to 6.023 times 10 power 23. And then the molar mass of iron is 56 grams, which is equals to 1 mole, which is equals to 6.023 times 10 power 23 particles. So a molecule also usually has a mass referred to as relative molecular mass, or RMM. So the relative molecular mass is usually the sum of the relative atomic. You see from the word atom. So if you take the atoms in the molecule and you add their masses, you get the relative molecular mass. So the number of atoms making a molecule is usually referred to as atomicity, which we are going to look at later on again. So for example, gaseous molecules, there are some that are diatomic, others are monoatomic. So the diatomic ones, the ones that are made up of the same elements like oxygen, hydrogen, nitrogen, fluorine, chlorine, bromine, and iodine. We have also some monoatomic ions, which are group 8, and these helium, argon, neon, and xenon. And also we have an exception for ozone, which has 3 atoms. So when we look at the molecular mass of oxygen, it's going to be 16 plus 16, which will give us 32. But this is also 1 mole of oxygen molecule. So 1 mole of oxygen molecule is equals to 32 grams, which is the same as 6.023 times 10 power 23. Hope you can see the difference. That one we are talking about atoms, but it doesn't change the Avogadro's number or constant. So the molecular mass of chlorine, which is Cl2, you add the 2, 35.5 plus 35.5, which gives us 71, which is the same as 1 mole, which is equal to 6.023 times 10 power 23. The same case in nitrogen as well. So the atomic mass of nitrogen is 14. Since there are 2, you add them to give you 28. So 6.023 times 10, 23 particles of nitrogen is equals to 1 mole, which is equals to 28 grams. So another is the compound. So we have talked about the atom, we have talked about the molecule, now we talk about the compound. If you take the masses, the mass of a compound, it's usually referred to as relative formula mass. It is the sum of the atomic masses in the elements that makes up the compound. So, for example, if you take water, water is made up of 2 hydrogens and 1 oxygen. So it means it's 1 times 2 plus 16, which gives us 18 grams. So 1 mole of water molecule is 18 grams, which is equal to 6.023 times 10 power 23 particles of water. But if we were to look at individual now particles, we have two particles of hydrogen gas. So if we were to look at those 2 particles in 1 mole, it would be times 2. If we were to look at the particles of oxygen, it would be times 1. Same case with sulfuric acid, the relative formula mass is going to be 1 times 2 for hydrogen, and then plus 32 for sulfur, and 16 times 4, where 16 is for oxygen. So examples of some questions in regards to what we have discussed. So calculate the number of atoms present in. So we are going to look at 0.23 grams of dilute sulfuric acid. So when it comes to dilute sulfuric acid, we know 6.0. So you see, we have been given the Avogadro's constant as is what we have been given. So you are not going to use 6.023, we are going to use 6.0 that we have been given. So 6.0 times 10 power 23 or particles of sulfuric acid is equals to 1 mole of sulfuric acid, which is the same mass. When you look at the molecular mass of sulfuric acid, it's going to be H2SO4. We do not need to use it in this case. So we are going to use the particles and the moles, and we can use the grams as well because we have been given the mass. So let's calculate the molecular mass. This is 1 times 2 plus 32 plus 16 times 4. So this is going to give us 98, as we saw also in the previous question, 98 grams. So the question is the number of atoms. So we know that 6.0 times 10 power 23 atoms is equals to 1 mole, which is equals to 98 grams. What about 0.23 grams will have how many? So this is going to be our method 1, because you can still do it in another way. But the second method, we will have to introduce a different formula. So we will use this for now. So we have used this relationship between the particles, moles, and molecular mass. In this case, we cannot use moles yet. We have not been given moles, we have been given mass. So we relate the particles to the molecular mass. So we said 6.0 times 10 power 23 atoms are equals to 98 grams. What about 0.23? We cross multiply, which is going to give us 6.0 times 10 power 23 times 0.23 grams, we divide by 98 grams. So this is going to give us 1.40816 times 10 power 21. These are the number of atoms. Let's look at one more example. So we are calculating the number of atoms in 0.23 grams of sodium carbonate decahydrate. So you look at that formula is going to be sodium carbonate. It is important for you to know the correct formula. So it's 10 molecules of water because you've been told it's decahydrate. So if you look at the molecular mass of sodium, this is going to be 23 times 2. Carbon is 12, oxygen is 16 times 3 plus 20 times 1. The reason why I've said 20 is because this 10 is the coefficient. So 10 applies for both. So you're going to multiply both. So 10 times 2, which gives you 20, but the hydrogen, the atomic mass is 1. Then you can see we have 1 oxygen multiplied by 10, so they are 10. So 16 times 10. So this gives us, when you add all this together, it gives us 286. So we go back to what we said. So remember, we had already been given the Avogadro's constant, which is 6.0 times 10 power 23, which is equals to 1 mole of sodium carbonate decahydrate, which is equals to the molecular or relative formula mass of sodium carbonate. So we are going to relate these two because we do not have the number of moles. We can calculate the number of moles though, but we are going to do so in the next session because we do not know the formula yet. So it's going to be 6.0 times 10 power 23 is equals to 286 grams. So what about 0.23 grams will give us how many particles? You cross multiply, which is 6.0 times 10 power 23 times 0.23 grams divided by 286. So this will give us 4.8252 times 10 power 20. So that brings us to the end. You can do more practice in the notes that are attached. So see you in the next session.